Okay. Hello, everyone, and welcome to another Perfect Scale webinar where we speak to exciting guests about all the important subjects in our industry. And today we have an especially important subject, which is sustainability and green software. And I'm very happy to have with me today Pini Reznik, who is the CEO and co-founder of a green software agency, European green software agency called cinq. And previously, Pini, you were the CTO at Container Solutions, so you're definitely no stranger in container land, in cloud land, in Kubernetes land.
Yes, yeah. We started in cloud native world from Docker days, early Docker days, which was way before cloud native term existed. Yeah.
So you're the perfect person to talk to about where these two important subjects meet. The cloud software that we're all running and building. Most of our audience are probably in the cloud software business, and software sustainability. So you're the person to talk to who want to understand how to make our cloud applications sustainable, how to understand if they're sustainable or not, how to understand what their carbon emissions are, etc., etc., etc. So with that, and without further ado, I'm passing you the mic. Maybe first start with telling a few words about yourself, and then give us your view on the issue.
Thank you. Yeah, so my name is Pini. I'm currently live in Netherlands, but originally from Israel. And so I'm doing some sort of software development operation, so software configuration management since end of 90s, a very long time. And in the last 10 years or so, I was building cloud native consultancy called Container Solutions, which basically built some of the largest cloud native systems in the world, really large enterprises. So we basically built those systems, and then once I finished with Container Solutions, the question was what's next, and sustainability was a somewhat obvious choice. So take those large enterprise, large scale carbon emitting systems and make them much lighter and emitting less. So that's what we do now is cinq, which is the goal of cinq is basically reduce carbon emissions. So I'll do a short presentation, and then we will continue talking about the same topic in different ways.
And while you're getting your slides ready, I'll just say that we're streaming this on LinkedIn Live and also on Zoom. So if you're on Zoom, feel free to send your questions to the chat. And if you're on LinkedIn Live, also type in your questions. We'll read them, and I'll ask Pini.
Yeah, something is going on with my laptop. It's okay, good. So first, is there climate change or not? I'm not going to answer this question really in depth or anything like that, because I sort of assume that if you came to this webinar, you believe that the scientists are right, yeah, and not the politicians. Sort of awkward thing to even consider, that we believe politicians more than the scientists. But basically, the idea is that the temperature is rising, and if it will rise a lot, there will be a lot of terrible problems, right? That's the general summary. And the assumption is that carbon or other gases, it's not particularly carbon, but other one, there are a few others. They create this greenhouse effect. I'm not going to talk about this. It's just, I basically assume that you believe in this. And what's happening now is basically we are emitting about 56 billion tons of carbon equivalents into atmosphere every year. And we know that this is not good for about 40 years. And the world took certain steps to reduce it, but generally the first major thing that happened was in beginning of 2000 or 2015, actually, the Paris Agreement, where we all, as a majority of the countries, agreed not to go beyond 1.5 degrees. The good thing is that most of the developed countries are actually past the peak of emissions and reducing their emissions quite quickly. So US, Europe, majority of the developed countries are actually on decline. So they're past the peak and they're on decline. It looks like China is also after the peak, but it only recently reached the peak. But there's a bunch of other countries, developing countries like India and Russia and Brazil, that are only starting their emissions journey. And you can see in the world graph and all the other ones, you can see a drop in 2020. That's the COVID, right? So during the year of COVID, the first year of COVID, when we stopped traveling, the emissions dropped by 5%. And the next year they picked up to the same level and continue growing. Right, so that's the effect
So
of
COVID was good for the planet, basically, what you're saying.
It's not good enough. You would expect more, right? But it wasn't more. It actually was quite minor decline. So, and also the other thing that people don't realize is that IT industry is actually major producer of emissions. According to different numbers, it's anywhere between 3 to 5% to 6%. So let's say 4 to 5%, which is more or less double airline industry, right? We like to dislike the airline this industry, but actually the IT industry, we produce double the emissions. And this is only projected to grow, and not just grow, projected to explode, especially due to AI and general digitalization of the entire world, right? So every industry becomes IT industry today. Banking industry, retail, everything is computerized. And yeah, so it's projected to go up to 14 to 17% of total worldwide emissions by 2040 if we do nothing about it. And the governments are really responding. And unfortunately, not all the governments, only some. The most advanced one is Europe. EU is responding with, this is the strongest program, Fit for 55, as part of Green Deal. It's basically the entire European Union across all the industries and everything committed to reduce carbon emissions by 55% by 2030 in 6 years. This is dramatic decrease, right? So, and if you think about this, if IT industry wants to grow to 10% for like double basically emissions by natural trend of growth trend, in the same time, it needs to halve the emissions, right? So that's going to be a significant challenge. And the major challenges that we see now, and we are doing it for last year or so, first, there's just lack of awareness. People just don't know what to do, and they don't even know they don't even know how much emissions produced by their anything. So there is no way to measure anything. There's no practical way, and generally, although there is a lot of talking about the priorities and sustainability is top priority, in reality, there is not enough budgets allocated, and the priority is not going down to engineering and operational teams. Right. So, and then even when you have motivated teams, they struggle to collect real-time metrics and insights. Right. So there's actually not enough tooling available to collect those insights. And insights need to be real-time, otherwise they are not actionable. Right. You cannot collect the information once a month because that doesn't help you to improve your software. And still, the priority of carbon emissions monitoring or is on reporting, government-driven reporting or regulation-driven reporting, and on marketing. So not actually reducing, but mostly talking about it and reporting to the government, right? We expect it to change in the next couple of years, because obviously governments are not putting in place all this regulation to just collect PDF reports, right? So that's not the final goal, right? The final goal is to actually drive reduction. So this is just setting the baseline from which the reduction will start in the next year or two. And when we talk about emissions, it's not particular in IT, in all the industries, they are divided into 3 scopes. The scope 1 is the direct emissions produced by things you burn, like you drive a car and you put fuel, petrol in the car and you drive it, then you directly emit emissions. So there are all kind of other processes that do the same, the cement production and steel production, and a variety of different things. Majority of them, not all of them, are burning carbon-based energy sources, but the majority is coming from that. Then there is second scope, which is basically everything that you are doing through electricity. So you consume electricity, for example, to power your servers, and then somebody else is burning coal in the power plants to generate electricity for you. That's indirect, and that's scope 2. And scope 3 is the supply chain. So everything you consume or sell to others. So for example, if you are running on public cloud, that's scope 3. Right, so it means that you don't own the servers or the building or whatever else, but somebody else is generating for you. So you still need to collect this information and report on it. So EU demands from, and all the other countries in the future will do the same, but basically you need to report on all 3 scopes. Scope 1 and 2 is a bit more easy because it's under your control. You know exactly what you own and what kind of devices you have. But scope 3 is much more complicated because you don't know how much energy actually AWS consuming when you're running servers in there. And what they have to do is to give you the emissions, not just from energy consumption from the servers, but also from everything around those servers, the building, the servers themselves, and the people driving to the office, driving to the, cooling, heating, everything else. So all of it is covered by carbon emissions. It's not just about energy consumption. So basically, there are 3 major places where, or major things you need to measure. So it's energy efficiency. So how much energy actually the devices or servers in our world, it's compute servers or storage or networking or anything related. So how much energy they consume. The second thing is hardware efficiency, because the server itself also generated carbon emissions were emitted while producing that server. So that's called embodied carbon, right? And the third part is carbon awareness, or in different words, it's what's the energy mix in the energy that you are using. So when you use electricity, it could be green electricity or coal-based electricity or something else. So you also need to be aware in which area you are running. For example, different countries have different energy mixes, so even different data centers have different energy mixes. So you can have the same server can be generating significantly less or more emissions depending on the energy source, right? So energy efficiency, hardware efficiency, and carbon awareness or carbon mix in the grid. And in different way, it's sort of same story in a different way, a bit more mathematic way. This SCI, which is definition by by Green Software Foundation, which is called software carbon intensity. So what we really want to achieve is this kind of unit per or carbon emissions per unit of your software or your service. Let's say you're building Twitter, right? For each tweet, which is R, you want to know what is E, which is energy consumed by the server, so everything else around to generate that with, multiplied by the energy intensity I in the grid, plus the embodied carbon in the servers used to generate that with. And that's per unit of the service. So once we have this actually carbon intensity, then we can start embedding that as a parameter, as KPI in our development processes and everywhere, so we can start reducing it. So at this point, it's not really measurable. Yeah. So, and there are tools, or at least the beginning of the tooling ecosystem around these things. So first, if we talk specifically about Kubernetes, more or less the only tool that will measure energy consumption within the Kubernetes is Kepler, right, which is open source. There are also some commercial tools, like Perfect Scale can show carbon intensity also in different way. Kepler will also somewhat show the carbon emissions, right? But it will do very rough estimation. The problem with Kepler, it's limited to Kubernetes only. It doesn't work in other environments. It also doesn't work on-prem, I think. It will work on-prem. It just have to be in Kubernetes. But it also will not consider the things below Kubernetes. Yeah.
I'm pretty sure it works on-prem because it's eBPF based, right?
It's eBPF based. It doesn't matter where it does. The other one, Scaphandra, will not work in the cloud because it connects directly to the hardware, to kernel. So Scaphandra is another one. Basically, those are the only tools in open source ecosystem that can provide energy consumption. Neither of them actually provides emissions. They do tell you the emissions, but it's very rough estimation, very imprecise, based on average use of the compute. So what we are building is this another open source project called Ether. We as cinq, with the goal to create much more precise and real-time emissions versus energy consumption. So we can collect information from Kepler or directly from the cloud and then present it in emissions instead of energy consumption. Yeah, so which is still open source, and we don't expect this to be a problem forever. So sooner or later, there will be a variety of different tools that will show carbon emissions in real time and in accurate way. It will take a few years until they're fully available, but this information will be available. And we really hope that the cloud vendors will actually produce or generate very accurate information and start producing something better than what they give today. The next level, you can also start going from infrastructure into profiling of the applications, more or less line by line, right? So still, absolute majority of the savings will happen on the infrastructure level, because the average utilization of hardware today, based on variety of surveys, is about 85% is waste. Average utilization is 15% of the hardware, right? So it basically means that the actual applications that we are running only consuming 15% of the hardware we have. So it means that majority of the optimization will happen in infrastructure level, just reducing the over provisioning and pure waste, right? But there's also a lot of work to do in the applications themselves, improve the algorithms, the tooling, the programming languages, etc. There are a couple of really good talks from ING and from Firefox that will go into detail on basically line by line profiling and emission or energy consumption evaluation. And the last part of this formula is the energy mix in the grid, right? And there are massive differences. So here is the example in In Sweden, you can have 23 grams per kilowatt hour, and in Poland, 721 grams, right? For basically same amount of energy generating massively more emissions, because Poland is almost entirely coal-based and Sweden is almost entirely green, right? So those differences are massive. Netherlands is, for example, about midway, 300 something. And this is changing throughout the day, right? So it means that if there is sun or wind, then obviously there is more renewable energy and the rest is coming from non-renewable, right? And in some countries like France, which is green, it's green not because of renewables, but because of nuclear, because it doesn't generate carbon emissions. So this is, like you say, there's massive consideration in that. So it's not just about reducing the waste, it's also about choosing the right place to run the loads. And we shouldn't forget about embodied carbon, right? So embodied carbon is, again, the carbon that was emitted while producing the server itself. This is an example of pretty standard server from Dell, and it's over 7 tons of emissions before the server was switched on. Right? It means that it's very important to use this server for as long as possible to basically spread these emissions over a longer period of time. In servers, it's about 20% or so of emissions coming from the hardware itself. If you talk about laptops and phones, about 85% of the emissions come from the device itself before it was actually sold. Right, so it's very important to extend the life of the hardware. And generally, the first few steps in reducing carbon emissions are actually quite simple, because we are just over provisioning like crazy. We are compensating for every problem in development by throwing more hardware on it, right? This is basically the most common way to solve problems in software development, is just add more hardware. And we accept the cost, the financial cost, but we absolutely cannot accept the cost of carbon emissions. So that's why we need to reduce this waste. And the fourth set of best practices are quite simple. So don't run things you don't need, shut down unneeded servers, squeeze more loads into the same server. Currently, ARM architecture is much more efficient than x86. There are all kinds of reasons for that. Yeah, and there are a couple other examples of specific patterns of that we met recently. We saw this company that they had pretty stable load on all the machines throughout the day, with spikes in predictable times, right? So it's like cron jobs sort of, right? And then they over provision higher than that, right? So tools like Perfect Scale or other cost optimization tools would just not use the unneeded hardware, right? So it would help to basically return the unneeded hardware back to the cloud. And you can save 40–50% of your hardware and hardware cost, cloud cost, just by not using the hardware you don't need. Right? And there's a variety of other things like not taking care of the memory consumption, like if you work with Java, not defining proper memory boundaries, then Java takes all the memory, and then and you have certain applications that you ask for double or triple the CPU you actually need. So there's actually no need for that. We really need to get back to the point where the hardware was a limiting factor. There was some sort of boundary and extra cost to use more hardware. And at this point, we're just over provisioning without any any reasonable boundaries. There's a lot of other things we can do, right? So replace heavier tools with lighter ones. Yeah, there's plenty of reasonably easy ways without re-architecting the application to reduce emissions by anywhere between 40 to 60% in matter of weeks or months. So in summary, basically in our experience, the infrastructure saving, so the optimization on infrastructure level and containers, VMs, and everything related to that is about 50% in a typical company, right? It's quite achievable goal to basically get to 50% reduction. Another 20 to 30% is improvement in the application itself. And then there is tooling. So we can also use lighter tools that generate less emissions. And this is before talking about hardware. I recently visited this very nice company in Holland that they are building immersive cooling solutions. So basically, it's like a bath with liquid where you stick servers in, and then and they cool like in cars, like liquid cooling instead of air cooling. That also just that reduces the energy consumption by about 40%. So in summary, it's very likely that we can actually build the same amount of software with about 10 or 15% of the hardware that we are using right now, right? It's that wasteful. So when we talk about 5% of total carbon emissions in the world and projected to grow to 14% in 15 years, then we just can't afford it, right? We really need to start doing those things and start embedding those green software practices in our daily software development. And that's it about that. And now we can go to questions.
Yeah, let's go back to the previous slide. We'll get to this one later.
Yeah.
Well, thanks, Pini. That's like very interesting because I'm sure I know this about me, and I'm sure many of our listeners, they've been asking these questions. Like, you know, once in a while we all get aware of all the buzz around, you know, the climate change, and we do realize that the air isn't getting cleaner, and you know, especially living in Israel, we do realize that each summer it gets hotter. So yeah. Definitely we can feel this on our own skin. But then, you know, you don't think about this on day to day. And once in a while, you really want to dive deeper into this. And this was a great overview. So basically what I hear you saying is it actually even pays off to be aware of sustainability, of using less resources, because basically the practices you're giving us here, these are also the practices that will save money for your business, because basically you're saying use less resources, right?
There is a lot of overlap, but it's not one-to-one, right? So obviously when you shut down a server, that's good for everything. There is actually no good reason to keep a server up if you don't need it, right? This is the same as you are leaving the room and you need to switch off the light. And if your kids are not doing it, you get upset with them, right? So we just need to shut down unneeded resources, right? And return them to the vendor. This is 100% also saves cost. But there are other practices that are potentially not saving costs. For example, relocating the loads to greener area. So I don't see how that saves cost, because potentially the cost of running it in Norway is similar to cost running in Poland, right? But it's also not. So there is a bit of work related to being able to relocate, to dynamically relocate loads to the right location. But still, there is a lot of overlap, and I think there is at least 50% of the initial reduction can be achieved together with cost reduction.
Yeah, I can definitely see what you're saying there, because again, at perfect scale, what our solution does is we measure the actual utilization, resource utilization of containers running on Kubernetes. And we do see that most clusters out there are severely over provisioned on resources, because people are not measuring the actual utilization, they're guesstimating the utilization, and usually want to be on the safer side, right? Basically, it's something that's been happening in our industry since we started, putting things on cloud. Like before that, there was this understanding that we should probably care about how much resources our software consumes, because we were limited by the hardware servers we had in our data centers. Nowadays, it seems like most developers out there will say, okay, this needs more memory. Well, there's cloud, just buy more servers.
That's a decade or two of convincing us to that cloud is endless, right? And resources are cheap. Neither of those are true. Cloud is not endless, right? And that's why in many regions you can find, like, if you try to grab a bit more VMs, they are not available often, right? That's because the governments are actually putting limits on energy consumption by data centers. Some countries like Ireland, they basically banned new data centers. Countries like Netherlands, you can build a data center, but you can't get energy to it, right? So they're not endless, yeah, and also they are not cheap. You also see a lot of companies. We met this in previous company. We met this supermarkets chain that their cloud bill was like 80 million euro a year, right? And they made, yeah. So now it could be okay because it's a big company, right? But when they made calculations, they estimated that they could halve the bill if they do it on prem.
Wow.
So yeah, so it's not cheap, it's not endless, but it's easy to start, and it's easy to start with poor architecture. And then when you scale, it's much easier to grab more resources, right? Kubernetes, cloud, everything is automated, everything is auto scaling. You just give it the possibility to grow, and it will grow a bit like virus.
Okay, thanks. And we have a few questions from the audience. So Carlos is asking, when we talk about embedded emissions, like you mentioned, Pini, in the production of servers, how far can we deep dive? For example, building a nuclear power plant emits CO2, mining the uranium as well, and so on. Can it be more complex than it appears to measure this?
Look, everything is estimations. I mean, obviously, we can go in very, very, very long argument here, and where this question sort of goes in typically is that electric cars, right? They are not as green as they are perceived because the batteries take whatever to produce, and actually over the lifespan of Tesla, it's actually producing more emissions than a petrol car. And it's probably true. I don't actually know. It's actually not true, but it's close enough to consider it as true, right? The thing is that you have to have this kind of intermediate technologies, right? So you need to create something that disconnects us from burning fuel to consuming electricity, so we can then improve our electricity consumption. We need to get batteries, which are difficult and expensive, so later on we can produce something else to replace the batteries, right? We have to do it in an incremental way, and every step, like in evolution, has to be beneficial, right? So today, electric cars are just better than non-electric cars in most cases. So the same thing here. With servers, what we need to know about embodied carbon is the amount. The server vendor has to give us the amount of embodied carbon. And we know that basically consuming a thing like if I have a phone, I have a better example, right? The phone is 85% is embodied carbon, and only 15%, only 2% is energy, and another 15% is services around it. So if you buy it every year versus every 3 years, then obviously, you are reducing carbon emissions by extending the life of the device, right? And this is 3 years old iPhone, and it's not very different from the current one, right? So that's a good example of just why do we need to renew our infrastructure so often. I hope that answered the question, because I'm not totally confident. Right? Carlos will again if it's not the answer.
I'm sure. Like what I hear, it's a very wide array of questions inside that question, and the question was there basically: how can we dive deeper, and how deep can we dive? Again,
it's not for us. It's not for us to dive deeper. It's for the vendor. The vendors are working really hard. We spoke with many of them. They are working on reducing the electricity consumption, removing fans, moving to immersive cooling, reusing the heat produced by servers to heat the pools around them, and they're all kind of things that are server vendors and data centers vendors they're investing billions right now to reduce energy consumption.
Okay, here's another question, by the way. Some of our listeners may know this. All the big cloud providers now give us APIs that allow us to get the carbon emissions, right?
They are.
And so the question is, of course, how trustworthy do you think these APIs are, and the data in these APIs?
It's obviously a complicated question, because whatever they give us, right, we cannot check it, right? It's a very difficult question on many levels, but I can tell one simple thing. None of them gives you what you need, right? Because all of them are not real time, and they are not accurate, and they are not considering all the emissions in the data center. So some of them are better than others. I think Microsoft is the most advanced, and it considers everything, cooling, heating, everything, except the building. They also need to consider the building, but it's getting there. But the biggest problem is not even that, but it's not actionable, because most of the time you get it with billing data once a month, and it's not detailed per application or something, right? So if you want to optimize your applications, this information doesn't help you. It needs to be much more detailed in real time. And I'm confident, or hopeful maybe, that this will improve significantly under pressure from the governments and from the users like us.
Yeah, that's the goal. Yeah, that's also a place to mention that at Perfect Scale we realized that this connection between resource allocation and reducing waste, resource waste, and reducing cost to the CO2 emissions reduction pretty early, and we do have it in the tool. So while you're reducing the cost, you can also see the CO2 emission reduction. And we're specifically for the reason that you are saying, we're not just relying on the cloud providers APIs, but we're also augmenting this with our own algorithms within that.
And the way we do it is the right way to do it, let's say, is to collect the energy or resource utilization from a particular server or microservice or whatever. Or let's say you are running a container, you need to figure out how much CPU memory, networking, and storage it consumes. That needs to be converted to energy consumption based on the spec of the server. And that is problematic because energy profile is not linear, right? So more load there is on the server, there's sort of optimal, typically on most servers, the optimal load from energy perspective is about 80 to 90%. So you basically generate less emission if you load more on the servers, which should be obvious, right? Because when you switch on the servers, it started using electricity without doing anything. And then slowly, it sort of goes like this, right? So so energy consumption, but it's not linear, right? That needs to be converted to emissions, but for that, you need to know what's the energy mix in that specific region. And often data centers are not connected to the main grid, right? They have their own solar panels or their own energy profile. So you need to understand what's the BUE, the efficiency of the data center, right? So there are all kind of parameters like that. And then you need to attribute it to specific applications, because otherwise the developers who develop those applications, if they get a single number for the entire estate, it doesn't help them, right? So it needs to go into a lot more detail than it is now.
Okay, thanks, Pini. Okay, we have another question from Frank, which says an important part of software delivery is CI/CD pipelines, which may deploy many times a day to production. Such infrastructure often runs on Kubernetes and also has an environmental impact. I'd like to know if you're aware of any tooling that could help radiate the information.
I can tell you this is very significant. We recently been in a company that what they did, they achieved the ultimate goal of continuous delivery, provisioning testing environment for every PR. It sounds great. Practically, it's not great because it's not needed. Because in many cases, they didn't even run the tests on some of those environments. And then they would leave for 2 weeks and then they would automatically shut down, right? So there's often massive waste and massive, I mean, sometimes it's like half of the resource consumption coming from the development environments, or sometimes even more. So there is massive waste there. It needs to be much more optimal. Tools, not really. I mean, it's there's the same type of tools like with perfect scale, for example. I mean, if you have test cluster, it can be scaled. I assume it can be scaled down to nothing if it does nothing, right? So I guess that would help. But you probably want to go even further, right? You could probably want to make sure that developers are not over provisioning unneeded testing environments if you are not planning to do any testing. And if you do, then at least they shut them down, not when the perfect scale catches them empty, but actually as soon as they're done with testing. Right. So there's a lot of like cultural things and process things that are not going to be taken care of by tools.
Right. So it's not only about cost, it's about value. So if you're provisioning servers and nobody's using them, then
at the end,
a lot of value in that.
This is the point. At the end, I'm not saying let's go back in time and not develop software. No, I'm saying whatever you are using, use it. But whatever you are not using, like, why in the world would you run it, right? Obviously, because you don't care enough. And I'm saying, please do care. Yeah. And it's not just about the environment, it's also the cost.
Okay, cool.
It's also increases quality of the software. When you optimize it, you find all kind of terrible things. Like when you don't care about when things are falling apart and you throw more hardware in it, it generally decreases the quality of the software.
Yeah. So definitely, one thing this can be achieved by making cost as visible as possible, because once you start seeing these numbers, then somebody eventually will ask the question, we're paying like, I don't know, $100 every day for this environment. Why? Who's using that?
And if there's a good reason, that's fine, right? And there's then FinOps thing, except that FinOps is it's coming from the financial department, right? And the engineers don't really mind about the cost. So even psychologically and motivation wise, it's switching from cost to emissions likely to achieve better results.
Definitely, definitely. Okay. Another question from Thomas. We have a lot of questions. Does this tie in with repairing older hardware, and do we need a better model on when to replace old hardware that takes into account the embedded carbon?
So yes, and there are a couple of examples. Amazon recently announced that they're extending their lifespan of the server from, I think, from 5 to 6 years. And by that, they didn't just reduce the emissions, they saved $900 million, right? Which makes sense, yeah. The other, what's the other company? The always forget their name, but basically they are all about sustainability. So they said, we will use the old servers for 10 years. So basically they extended the lifespan of servers to 10 years. And they found out that actually the component that fails most of the time is hardware RAID controller. So they replaced it with software, because in modern servers it's software anyway. And then they find that 10 years is totally normal for a server. The thing is, of course, there's a bit of trade-off, because older servers are likely less optimized to lower energy consumption, but you already have them. So you need to actually understand the numbers and measure, right? So you understand what's the energy consumption. And if you can see that, let's say, extending the lifespan of a server by 2 years, it's almost always worth it. But sometimes it's such a terrible server in terms of energy consumption that maybe it's not worth it. Maybe it's going to use more energy than the embodied carbon. One of the problems in this world is a lot of it is non-intuitive. And without actually measuring, it's very difficult to say what's the right strategy.
Yeah.
But generally, the world is going towards cycle economy. So we need to use our stuff longer, right? And our vendors of the stuff, they need to build it more durable and with possibility to replace different pieces. Because like a server, if you want faster CPU, in the past we would replace a CPU and replace memory. And today it's not practical, right? You need to throw away, like a laptop, Mac laptop, you have to throw it away if you want a bit more memory, right? And buy another one for 3,000 euros something. Yeah. So it's not just expensive, it's also very, very, very wasteful.
Basically, use your stuff longer. That's the definition of sustainability, right? We want to use this planet a bit longer.
Use less stuff and use it for longer, and choose the ones that uses less energy, right? It's quite simple, right? It's just people, need to care more.
There's another interesting question in there. So yeah, one of your slides mentioned switching from x86 to ARM processors.
Yes.
So how, like, there are different opinions on that. Somebody I talked to recently said, yeah, they're cheaper, but you're getting less performance with them. So
okay, so there is no different opinions at all on energy consumption. They are consuming dramatically less energy, right? There's no question about that. Are they a good fit for your application? That's very questionable, right? That very much depends on a variety of things. First, if your application is not compiled for ARM, you need to rebuild it. And then what if your database doesn't run on ARM? And and then you go to all kinds of things. And then you find yourself in like a 2 years project to replace everything to ARM. Don't do that, right? That makes no sense at all, right? That's like, it's not worth it. It's like replacing Python is like 100 times more or less efficient in terms of carbon emissions than C, right? But you're not going to rebuild than Rust. Let's say C is a better example, but Rust is modern enough, right? But yeah, it's 100 times difference in terms of energy consumption, Rust versus Python, but no one more or less will recommend you to rebuild your application in Rust if it's written in Python, right? Because the compiler, the Python is changing and improving, right? And the work itself to rebuild it will also produce emissions. So it's not a good investment, right? So generally, when you start a new project, you always want to choose the greenest setup. And then you have an opportunity to choose ARM, right? Or a better language, or a better greener practices, or all kind of other things. But if you have old setup, then it's very questionable.
Okay. Okay. So for new projects, definitely consider using ARM, and also maybe more power efficient languages such as Rust instead of Python. But for old projects, first look for easier ways to reduce the emissions, right?
Yeah, they're typically easier ways, and then changing language is the last thing you want to do. Because
Yep.
changing language is basically rebuilding from scratch, right?
Yep, and that's a lot of manpower and also computer power.
And I rarely saw projects like that succeed regardless of their noble goals.
And then you also need to run things in parallel until you've migrated, and that's even more power consumption.
So let's focus on simple things first, right? That's the point, like shutting down unused hardware or extending the lifespan of your servers from 5 years to 6 years. Those things are reasonably easy and non-intrusive.
Yeah, gotcha. Okay, Pini, thanks a lot for this. It was very interesting, very important. And with that, I want to invite our listeners to our next webinar, where we'll be touching upon an equally interesting subject, and also somewhat related, because with the evolution of generative AI and large language models, that definitely impacts our power consumption, the amount of compute that we're running. So we'll be talking about the role of Gen AI in modern DevOps, and we'll be talking to none other than Patrick Debois, the man who coined the term DevOps more than 10 years ago, and who is now very much involved in researching the topic of general AI. He's one of the experts on the subject. Definitely very exciting and very, very relevant to everything that we're talking about here on these webinars. Pini, thank you. Thank you for coming. Definitely. So maybe let our listeners know how to reach you if they're interested to promote the sustainability initiatives at their companies, especially if they're in Europe. Do you also work with customers in the US?
Yeah, yes. Although we this is one of the interesting sort of side effects is that regulation is stronger in EU, so we see a lot more willingness to invest in sustainability in Europe compared to other countries, particularly US. So, but we are open to anywhere, and Resync here, we will follow up with a joint email later on, and with details of how to find us and other information.
Yeah, and folks can find you on LinkedIn, of course, and probably send you a
difficult
message.
to find, yes.
Yeah, and this is also a place to say that Perfect Scale, as I already mentioned, we have built in. It's again, we just during this webinar we definitely realized it's a very wide topic, and there are a lot of questions there. But if you want to quickly get started with understanding how much carbon emissions your Kubernetes clusters generates, then definitely give Perfect Scale a try. see how much resources you're maybe over provisioning, and also see how much carbon you can reduce. It's easy. Just get signed up at our website and start measuring.
Yeah. Thank you for
Thank
hosting.
you. Thank you for listening. And thank you, Pini.